Okay, so question A is asking, is the speed of the particle increasing or decreasing at t equals 5.5? And to know whether speed of the particle is increasing or decreasing, you have to know the sign of acceleration and velocity at t equals 5.5. So you could just plug in v of 5.5 equals, you're already given the velocity, so 2 sine e 5.5 divided by 4 plus 1. You just plug that into the calculator. 2 sine e to the power 2.5 divided by 4 plus 1, and that equals negative 0.53. And to find the acceleration, you're already given that as well. 0.5 equals 1/2 e 5.5 divided by 4 cosine e 5.5 by 4. Okay, so you can just plug that in too. E 5.5 divided by 4 cosine e and that equals negative 1.359. This is the thousandths place. Okay, so since the sign of velocity of 5.5 is negative, and the acceleration of 5.5 is also negative, since the signs of acceleration and velocity are the same, this means that it is increasing at t equals 5.5. Okay, so for B, it's asking for the average velocity of the particle for the time period 0 on its interval of this 0 to 6. Okay, so for average velocity, the general equation is to do 1 over b minus a and times the integral of the equation. So 6 minus 0, b is 6, a is 0. You multiply from 0 to 6, the integral of v of t dt. Okay, so for this, you could also you had to plug into the calculator. So 1 over 6 times math 9, 0 to 6, and then you just plug in v of t, which is already given, 2 sine e to the power of 5.5, x, which is actually t, 4 plus 1 dx. So this equals negative point. Wait, stop it. Okay, so you just plug this in to the calculator. You can do alpha y equals, for the fraction, 1 over 6 times math 9, 0 to 6. V of t is already given, so it's 2 sine e to the power of x. X is actually t, by 4 plus 1 d of x, or t of t, equals 1.949. So this right here is the average velocity. Average velocity at the interval of this right here. That's the interval. And okay, so that's done. C is asking for the total distance traveled by the particle from t equals 0 to t equals 6. So since it's asking for the total distance traveled and not the displacement, you would have to integrate it and make sure to use the absolute value of v of t. So it will be set up like this: 0 to 6 v of t, and you have to make sure you have the absolute value signs for the total distance, and that's what it's asking for, not the displacement. So you have to add the absolute value of d of t. So for this, you also just plug in. So you go to math 9 0 to 6, math, and then number, and then absolute value right there. So you just plug in v of t now. 2 sine e power of x divided by 4, which is actually t, plus 1 dx. So this equals 12.573. So this right here is the total distance traveled from t equals 0 to t equals 6. And for d is asking where the particle changes direction exactly once, from the interval of 0 to from 0 to 6. Okay, so since it's asking where it changes, where the particle changes direction, that means v of t is where v of t equals 0. And to find where v of t equals 0, when it equals 0, it shows whether the particle went from left to right or right to left, and you could see that by just plugging in. V of t is 2 sine e to not from right to left though, since it's just continuous like that. So e to the power of x 4 plus 1, and make sure the table says from 0 to 6. Now we'll hit graph. So it hits 0 right there, and you find what the x is by hitting second trace and then 0. Left bound could be anywhere, just pick wherever, and then right bound wherever, just from the other side. Okay, so t equals 5.1955223. So this is where the particle changes direction. So that's where the particle changes direction at least once, and this is where it is. And it's asking to find the position of the particle. To find the position of the particle, you have to use what's already given, and that is that x of 0 equals 2, and x of 0 is the particle where x of 0 is. So x, but you're trying to find what this is. 5.1952223 minus x of 0 equals, and this right here is the definition to find also like integral, which is the same thing, 0 to 5.1955223 v of t dt. So this is the same thing as this, but just integral form, and the antiderivative of this of v of t is the particle. So but you're trying to find this right here, what x of this number is right here. So you could just do x of 5.19 equals, and x of 0 is already given, so it's just 2. X of 0 is just 2, so it's just 2. You can add x of 0, x of 0, so it's just 2 plus 0, 5.195 of t dt, and you can just plug that into the calculator. You already have y1 as v of t, so you just do 2 plus math 9 from 0 to 5.195523, variable, y variable function y1, dx or dt pretty much. So x of 5.195523 equals 14.135. So 14.135 is what the value of the position is where it changes direction, and this is the answer to the position of the particle at that time.